than having torrential rain falling. So what I'm going to talk to you about today is about fragipans and what are their features and what problems they cause and how did they form and what the extent of them are in the United States and all around the world. And the wind is not very cooperative, but that breeze feels good, doesn't it?
Yeah.
So if we try to define actually the fragipans are subsurface soil layers. And I emphasize soil layers. They're not like sandstones or bedrock or anything like this, although they may pose similar restrictions. So they're soil layers that they have been cemented or compacted or indurated through natural processes. It wasn't a man-made or trafficking or heavy machinery that caused that. It was done 20 to 50,000 years ago through natural processes. And these processes were physical and chemical processes. Now, their extreme density and compaction obviously poses some problems as to root penetration and water penetration. And if you have root penetration and water penetration restrictions, obviously that will affect your yield, your crop yield. So this problem has been around forever. We're not the first ones really to address it. There are several people in the past that they tried to do something about it because they knew that if they find a solution to it, to remediate somewhat this restrictive layer, then the farmers will appreciate that and will increase their income and it will increase production and so forth. Now, what is causing this cementation of the fragipan? Like I said, it's a natural process. It's a physical-chemical process. Well, we did some research on that, and not only us, but other people as well. And we found out that what is causing that cementation is certain aluminosilicate minerals, amorphous, that they're acting as a glue to cement those soil particles together. How many of you have seen a sandstone? You know how it looks like, right? Do you know what is the cementing agent of sandstone? Obviously, a sandstone is made up by sand grains, right? Do you know what is cementing those sand grains? Silica. Excess amount of silica. Sandstones usually are made up by silicon dioxide minerals, and when those dissolve, they release that silica solution, and that silica, when it dries out, it becomes like glass. And that's how sandstones are forming. Well, a similar process, not to that extent, happened actually with the fragipans. And I said not to that extent because fragipans are 20 to 50,000 year old features, while sandstones may be millions of years features that they have formed under different conditions. So what are the typical characteristics of a fragipan? Well, first of all, the first thing you will see is a very distinct coarse prismatic structure. In 2 dimensions, you can see actually those prisms just being delineated by diagonal or gray streaks. But if you see them actually from the top, this is how they look like. Polygonal structure. These are the prisms. This is an example of prisms that they have been extracted actually from a Fragipan horizon. These are about 6 to 8 inches across. Huge prisms. Now that is what is causing actually the restriction of water and root penetration. Because the only avenues for water movement through a fragipan are those gray streaks. That's why they're gray, because water goes through. If water goes through, the roots will go through as well. But if you look at the overall picture, only 30% or less of that fragipan in most cases is covered by those gray streaks. The rest of it is made up by those prisms, the coarse prisms, which are restrictive to root and water penetration. What else? A lot of people think that actually what is causing these fragipan horizons or layers to be restrictive is a lot of clay. Absolutely not true. Most of these fragipan horizons don't have more than 35% clay. A lot of them actually will be in the 20s. So it's not the clay really that is causing this restriction. Now, if you take a material from a fragipan horizon, let's say a cloud, and moist, right, in a moist state. Now, this time actually, this pit, you have exposed prisms that they're relatively dry. But if it's moist, almost water saturated to the extent that it can, and you put it between your fingers and you compress it, try to compress it, right? Apply pressure, as much pressure as you can. It's not going to deform. Unlike a soil clod, a regular soil clod, if it's moist and you compress it like this, this is what's going to happen. It's going to get flatter, flatter, and flatter, right? Mm-hmm. So this one, the fragipan, is not going to act like this or react like this. What's going to happen is, as you apply more and more pressure, if you don't break your fingers, that is, that thing is going to explode. Now that is what we call brittleness. And that comes from a Latin word, actually, fragilis, that's where fragipans were called from, it means brittle material. So that's what is the property of brittleness. When it erupts, it explodes instead of deforms. Another property that fragipans have is they slake in water. If you put a natural soil material in a water beaker, for example, a water jar, okay, a jar of water, what's going to happen in half an hour? It's going to disperse, disperse, and disperse, and finally you're going to have a sediment layer in the bottom of that jar, right? Now, try to do the same thing with a clod from a fragipan soil. It's not going to happen. What's going to happen over time, I'm not talking half an hour, you're going to start seeing some flakes from the sides kind of falling apart. So it is reacting to water. It is not that it is not reacting to water. It is, but very, very slowly. And that's important because if we allow this fragipans to do anything about it, okay, let them go. It took 20 to 50,000 years to form, right? Maybe in 50,000 years interacting with water, they start breaking down, right? Are you willing to wait that long? No. We need to do something actually as soon as possible so we can get immediate results or at least short-term results. That's why we started this research that we have been doing for the last 6 or 7 years. We're not the first that we have attempted that, but most of others that they have not had any success. So we have some promising results that hopefully, actually with a little longer period of time, they will materialize in actually some benefits to you guys and ladies. So these fragipan prisms are impermeable or very slowly permeable to water. So the only avenue, like I said, is between the prisms through the gray streaks. In wet years, if you have a lot of water that is percolating through the soil, so if that water actually reaches the top of the fragipan, what happens is the fragipan cannot absorb that water, the gray streaks cannot absorb that water, so what is causing is what we call a perch water tape on top have a perch water table that it is persistent for long periods of time, particularly in very wet years, what happens to the roots of the plants growing there?
They can die off.
They're going to die eventually because roots need oxygen, right?
Yep.
If you deprive them from oxygen and you make that environment for long periods anaerobic, they're going to die. They're going to drown. So that's a problem actually that is being caused in fragipan soils in very wet years. It's not only the dry years now that we have a problem. What problem we have in dry years?
Not enough water.
Not enough water. Not enough water. Because the roots can explore only that good part of the soil. They cannot go through the pan. Particularly if that pan is pretty close to the surface. And I have seen some that they're all the way to 10 inches or less, particularly in eroded landscapes. Can you imagine growing crops on a 10-inch good soil? So this is how actually a kind of an ideal diagram of a fragipan soil will look like. You see you have a surface layer which has good organic matter content, a subsoil layer that it is suitable for crop growth and root penetration, and then immediately after you have these huge prisms. And the only avenues, like I said, for water and root to penetrate are those gray streaks. One property that I mentioned earlier that it is characteristic of fragipans is slaking in water. Now, slaking is this flaking effect that I was telling you earlier. Not dispersion, but flaking. So it resists actually in falling apart when you immerse them in water. So this is a picture of that actually. So you see a cloud of fragipan material immersed in water, and it just on the sides you have a little flake falling apart, but that thing remains there for a long period of time. Now here is an experiment that we conducted early on. So what we did, we immersed the clone of the fragipan taken from this particular site here, all right, in water, the ionized water, okay? And this is a picture, you see the jar there, all of you do? Can you, or am I blocking you? You may have to sit this way if you like. And this is a picture taken after 7 days. What happened to that cloth?
Stayed the same.
Absolutely nothing, right? Absolutely nothing. It stayed there rigid, you know, as it was when I put it there. Now, I did the same thing, but instead of water now, I use a ryegrass root extract. So how did I get the extract? Well, we got some ryegrass roots and we boil them, you know, in water. And we strain them and we use that extract, that solution. And that's what we use instead of water. And we immerse there a similar kind of a cloth, taken again from here. Now this is a picture taken 7 days. You cannot see it clearly because the ryegrass root extract has a little color to it because of its organics, right? But if you look closely, you see it started already falling apart. A better picture you can see in 30 days, after 1 month, the same jars, right? This is what we got with a cloth that it was immersed in water. This is what we got with the cloth that it was immersed in ryegrass root extract. Hey! And this was replicated, I would say 20 or 30 times, with even different ryegrass varieties. Consistency, consistent. That's what happened. Now that's something to look for, right? Or look more to it. And that's what we did. We did not use only ryegrass root extract. We used other cover crops, wheat and hairy vets and other things, turnips, and you will see down in other stations all the experiments that we did, more than 50 different treatments. None of them gave us the consistency that rye root extract did. And I say rye root extract. We did experiments with shoots of ryegrass, and we had actually similar results with shoots. So after you kill the ryegrass, actually, though that residue that remains on the surface can still percolate down, and those organic substances that it releases, it may enhance actually the breakdown of the fragipan. So it's not only the roots, it's the shoots as well, the overground material. Fragipans, like I say, they are not found only in Kentucky. They're throughout the world. They are in Europe, they're in China, they're in Africa, and in the United States, they're in this area. Many states around here, they have them. They're in the Northeast and in the Northwest. So they're not unique to our state or in our area. They may have different expression of brittleness or rigidity or restriction or even different features, but they're still considered to be fragipans. There are about 50 million acres of fragipan soils in the U.S. In Kentucky, we have 25 to 30% of the state occupied by areas having fragipans. Can you imagine that? Why in the heck we didn't do anything about it before?
Awesome.
Yes.
We've got about 5 more minutes left.
Okay.
Your time up equally.
So we said that they impede water drainage and root growth, and they cause, obviously, because of that significant crop yield reduction. We estimated about 25% yield reduction from an average soil that doesn't have a fragipan. I will turn it around and show you actually a couple of things about how we think these fragipans form. As I said, these were formed about 20 to 50,000 years ago. Unfortunately, we're not there to be present and verify that, but obviously we have some theories based on records and reports. And during that time, when those glaciers, we have glaciation phenomena at that time. When those glaciers melted, actually they flooded the entire low landscapes in Kentucky and other states around. So when they flooded them, they formed lakes and ponds. After that, immediately after that, we have a very dry climatic period, long climatic period, during which these lakes and ponds dried out. And there was a west to east blowing wind that blew actually loess or silty material that covered those lakes. So if you look at this dry lake bed picture, right? You see that? Have any of you seen this? A dry lake or a dry pond, you know, during a dry period of time? Okay. And if you see the top of a fragipan, like I said, that I plowed, and this is the top view, do you see any similarities? Do you see the polygonal structure? The only difference is that this has actually cracks, that they are open. In this case, they're filled out, right? So this filling happened for loss blowing material. So what happened then next? This loss blowing material had a lot of weatherable minerals that they're in the group of feldspars. Feldspars have a lot of aluminum and particularly silica, a lot of silica in them. When that silica dissolved, remember what happens to sandstones?
Cemented it.
Cemented. And it cemented particularly those polygons, those prisms, because the fluffy material on top didn't have anything really to be cemented with. This was the restriction that you had initially. So actually the soil now, it's forming on top of the prisms, and then you have these solutions that they are saturated with silica going down, and they're standing on top or percolating somewhat slowly through those prisms. And during dry periods, that's how the cementation occurs. Since I have very little time, I'm just showing you a couple of examples of these soils. This is a saddle-leaf soil, which is typical in western coalfields, Grenada, in the western Purchase region, Tilsit in the bluegrass, and Zanesville. This picture actually was taken from this side here as well. You will see on other sides actually what we have done in the lab and in the field, and what data we have to support ryegrass as being one option in breaking down the pan. And also we have a guy here that will tell you something about the economics. And if you have any questions right now, go ahead.